Speed and velocity are two similar words, but in physics they are different. One is a scalar quantity that just needs a size or a magnitude, which means it needs a number to give the quantity a meaning. And the other is a vector, which needs a magnitude and a direction to fully describe that quantity. Speed is a scalar quantity, and velocity is a vector quantity. Here's two examples to show you the difference. A traffic policeman just needs to measure the speed of your car in case you're breaking the law. He's not interested in the direction you're speeding. What he's measuring in this case is a scalar quantity in the form of speed. But the pilot of the space shuttle needs to know how fast it's travelling and in what direction for it to land safely. What he's measuring here is velocity, a vector quantity, having size and direction. Speeds and velocity are calculated differently. More often than not, it is the average speed or velocity we want to measure. Now, the average speed is given by this expression here. The average speed is the distance gone divided by the time taken. Note the average speed is given the symbol v with a line on top. This is pronounced v bar. The average velocity, on the other hand, is equal to the displacement divided by the time taken. Once again, the average velocity is pronounced v bar, and the symbol for displacement is small s. So there we have the two different equations of working out the average speed and the average velocity. Average speed is the distance gone over the time taken, but the average velocity is displacement, which is a vector, divided by the time taken, and displacement is given the symbol s. Here's an example on how to calculate the average speed and average velocity of a journey. The picture you see is the surface of the moon moments after Apollo 17 blasted off. The tracks you see were made by the moon buggy, which drove about the surface. And in the grey box, we've got the record of the journey of one of those buggy movements. 3 kilometres north from our starting point, then 4 kilometres west, then it stopped, and then the time taken was measured to be 2 hours. So the first thing we've got to do is draw a scale diagram of all the displacements. So we start off at the start. Here is our start point here, there. The little white dot is the starting off point. Now we've got to draw a 3 kilometres north vector. Now to do that, we're going to use this ruler here, and we're going to use the scale, which you can use in your worksheets, of 1 centimetre on your ruler is going to stand for 1 kilometre. That's going to be our scale. And on the ruler here, 1 centimetre is a wee bit big because it's a on-screen ruler. That is 1 centimetre there. So line your ruler up, 0 at the start, heading north, and we'll draw in our north vector, which will represent by that yellow vector arrow there. And there it is, bang on 3 centimetres, which means it's 3 kilometres. Our next instruction is to go 4 kilometres west, so we have to turn our ruler round, and we have to position the ruler here and draw in our next vector, which is going to be 4 kilometres west, so that will be 4 centimetres on your scale diagram, and that will be there. And you can see that the tail of one vector nestles into the nose of the other vector. So we can take our ruler away right now. We can fill in our values. We have gone 3 kilometres north, our first displacement vector, and we've gone 4 kilometres to the west for our next vector. And that's where we stop. So we put our finishing flag just before that little crater there. So the resultant displacement is going to be a direct line from the start to the finish. And we draw the arrow like this, from the start to the finish. And that's going to be our resultant vector. So all we have to do is measure the size of it with a ruler and the direction from north. So we'll use the ruler first, and we'll spin the ruler round, And if we position the ruler here, you can see the distance is 5 centimetres. And that's quite good because we're dealing with a 3, 4, 5 triangle. So the displacement length is going to be 5 centimetres, which in our map will be 5 kilometres. So that's going to be a distance in there of 5 kilometres. The next thing we have to do is work out the direction from north. So to do that, we have to first of all draw in a north line. So starting at start, draw a line up to represent north. And then bring your protractor over, position so that the centre point here is at the start point. So that's bang on there. And the 0 line, the north line, will be right up through the 0 degrees for north. Now we can read the angle now. It's going to be 50, 51, 52, 53 degrees. So the angle is 53 degrees. So now we have everything we need to know about that vector. We know it's an angle of 53 degrees from the north and its length is 5 kilometres. And we draw 2 little lines like that, 2 little arrows, to show that's the resultant vector. Now, let's analyse what's been happening. We look at our map and we can find out that the total distance gone is going to be 3 kilometres plus 4 kilometres. So the total distance is actually 7 kilometres. The displacement is different. That's a vector. It needs a size and a direction. So the displacement is going to be 5 kilometres and on a bearing of 0.53 degrees. So that's our distance and that's our displacement. You can see they're different because distance is a scalar and displacement is a vector. So now let's try and work out the velocity and the average velocity and the average speed. Now we know from our equation work that the average speed is the distance gone over the time taken. We can write down a formula like that. And the formula reads V bar equals distance over time taken. Remember, the bar signifies as an average speed. So all we have to do now is fill in those numbers. So the average speed, V bar, is going to go to the distance gone, which we found out was 7 kilometres. And we're going to divide that by the time of 2 hours. So that's going to give us an average speed of 7 divided by 2 is going to give us 3.5 kilometres per hour. There's no direction involved because average speed is a scalar. But what about the average velocity? Well, the average velocity is calculated by a different formula. Average velocity is equal to displacement divided by the time taken. In equation form, we have V bar equals S divided by T. Remember, S stands for the displacement. And we've worked out what the displacement is. So we put in our numbers, we can find out the average velocity is going to equal the displacement, which is 5 kilometres, divided by the time taken, 2 hours. And remember, the direction in a 3-figure bearing is 0.53. So our average velocity is going to be 5 kilometres divided by 2 is going to be 2.5 kilometres per hour. And because it's a vector, you have to include that direction to give it the full meaning. You can put the degrees in if you want. So that's how we calculate the average speed, and that's how we calculate the average velocity. Both different.